Today we study the Calculus 1. We study the rigorous study of limits. So now look at the simple description. The first, this means epsilon, Greek letter, stands for arbitrary positive number, usually very small. The second, dot, Greek letter, stands for arbitrary positive number. This means for any, means any given number. The first means exist. There exists at least one. To find. This means f(x) is within epsilon of L. f(x), all the function value, less in the open interval between capital L minus epsilon and capital L plus epsilon. This means the interval x larger than c minus delta, less than c plus delta, including c, x is sufficiently close to c. This means difference less than 0. This means requires that x equals c be excluded. This means x is sufficiently close to c but different from c. This means doesn't include the point c. Now look at this new definition, neighborhood. This means neighborhood, some set of variables. Let a and delta be real numbers and delta be any positive real number set. The set means the group of some variable x be the delta neighborhood of the point A, which is written as this form. U bracket A delta require that the variable x satisfying this expression, x larger than A minus delta and less than A plus delta. This means A is regarded as center, delta is regarded as the radius. Look at the following geometrical meaning. Now look at center point and then the radius delta. The right point A plus delta, the left point A minus delta, all the points lie in the open interval. Try to understand the geometrical meaning. Now look at the figure. The center point is A, radius is delta. All the points lie in the open interval. UA delta means x larger than A minus delta and less than A plus delta. Sometimes UA delta is written as this form. UA means we don't care the values of delta. Look at this expression. How about the difference? Yes, the red circle. The red circle means x minus A absolute value less than delta. Pay attention to less than 0. This means x doesn't equal A. Look at this. If the open interval A minus delta to A, the point from the left open interval, this means the left neighborhood of delta, corresponding the open interval A to A plus delta. This means the right neighborhood of delta. How about the right open interval? Now look at, in the mathematical language, how to express variable attached to some fixed point x0. How to express the function value tend to the capital L, some fixed point, in the mathematical language. For any epsilon less than 0, absolute value f minus L less than epsilon. This means for every epsilon means usually small. Fx is as close as we like to L, means the values of function fx and L, they are closed. There exists delta less than 0. x minus x 0 corresponding to absolute value between 0 and delta. This means x is sufficiently close to the point x0, but doesn't equal the point, means but different from x0. X doesn't equal x0, the given point. Look at the figure. This means x0 is the fixed point. Delta, some fixed number. Look at this. The right point, x0 plus delta. The left point, x0 minus delta. All the points less in the open intervals. Now look at how to express the limit using the mathematical language, means the precise meaning of limit. For any eventual than 0, there exists delta less than 0 such that if x satisfying this expression, this means x is sufficiently close to x0 but different from x0, only tends to the point but not equal the point. We always have the absolute value of fx minus L less than eventual. At this time, we will write limit fx equals L under the condition x tends to x0. Pay attention to the condition x tends to the point not equal. Sometimes we write x tends to x0 corresponding function values tends to L. That means x minus x0, the absolute value between 0 and delta. We have this expression. Pay attention to eventual less than 0. No matter how small, there is always a corresponding delta less than 0. Corresponding means eventual is given, delta will be founded. Eventual is changeable, delta will be changeable. Delta is determined by the eventual. So now look at the geometrical meaning of the limit. For eventual less than 0, there exists delta less than 0. If x minus x0 absolute value less than 0 and less than delta, x0 and x satisfying this x minus x0 less than 0 less than eventual, always we can find all the function value between L minus eventual and L plus eventual. Now, this means the function values of x lies in the domain. Look at the figure. The pink curve y equals fx. This is our L, corresponding L minus eventual, L plus eventual. We can draw in corresponding the figure. How about x? This is the fixed point x0. x0 minus eventual, x0 plus eventual. X is changeable in these two open intervals. If changeable, all the function values less in this interval. Try to understand the figure. Now look at the definition, left hand and right hand limits. Look at this. Left hand limit. How about left? Look at this. For any eventual less than 0, there exists delta less than 0, such that if x less than x0 minus delta less than x0, this means x less in the left neighborhood. We always have absolute value fx minus L less than eventual. At this time, write it as limit fx equals L. Sometimes write it f bracket x0, pay attention to minus. This means x tends to x0 from the left side equals L. Corresponding in the similar way, we have the definition right hand limit. For any eventual less than 0, there exists delta less than 0, such that if x is changeable in the left, no, right neighborhood of delta. X larger than x0 less than x0 plus delta. We have this expression. At this time, rated as limit x tends to x0 plus fx. At this time, the limit equals 0. Pay attention to x0 plus. Plus means x tends to x0 from the right side. Look at this. X minus x0 absolute value between 0 and delta. This means corresponding some delta neighborhood equals the union of the two open intervals x minus x0 between 0 and delta. Another x minus x0 between minus delta and delta. This is one set equals the union of the two sets. According to this relationship, we will have the following property. The limit fx equals 0. If x tends to x0, if and only if, this means equivalently, the left-hand limit and the right-hand limit exist, and the two corresponding limits are equal, which means the two limits exist and the two values should be equal. At this time, the limit will exist. Pay attention to the property. We will use the property to finish some question. Now look at example 1. Prove the limit c equals c. Pay attention to the condition x tends to x0. x0 means some given fixed point. C is any constant. How to prove? Think it by the definition of limit. For any integer less than 0, try to find the delta. How about delta? In this question, for any delta less than 0. If x minus x0 absolute value less than 0 less than delta, we always have fx minus L. How about fx in this question? Limit c equals c. So in this special question, fx is c, L is the limit c, so equals c minus c. The two same real numbers, c minus c always equals 0. 0 always less than epsilon, so we don't care the values of delta, so means for any delta. At this time, the limit c equals c if x tends to x0. How to prove? According to the definition of limit. Now look at example 2. Prove the limit fx if x tends to 1 equals 2. Look at the question. X tends to some fixed point. In this question, x0 equals 1. How about the limit? The limit means capital L in this question equals 2. Fx is not defined at the point x equals 1. How to write it? Because fx minus L copy fx. Copy x squared minus 1 over x minus 1. Copy L. L equals 2 minus 2. Together we can get it x minus 1. For any epsilon less than 0, in order 2, the absolute value f minus L less than epsilon. Yes, f minus L equals x minus 1. So, need to take delta equals epsilon. Build up the relationship between epsilon and delta. This means epsilon is given, we can find the corresponding delta. Delta equals epsilon. So, if x minus 1 less than 0 less than delta, we always have fx minus 2 absolute value less than epsilon. This means less than delta. So limit fx x tends to 1 equals 2. We have proved the question. Now look at example 3. Prove fx equals square root x if x less than 1. Fx equals sin x if x larger than or equal to 1 has no limit. Under the condition x tends to 1, the result is given has no limit. How to prove? According to our property. So now look at this. The limit x tends to 1 minus. How about 1 minus? This means x tends to 1 from the left side. X tends to 1 minus. How about fx? This means x less than 1. X less than 1. At this time, the function is present means square root x. The limit x tends to 1 from the left side, square root x. The limit equals square root 1. Square root 1 equals 1. It is the left-hand limit. How about the right-hand limit? X tends to 1 plus. 1 plus means x tends to 1 from the right side. Right side, at this time, x larger than 1, but doesn't equal 1, tends to 1 from the right side means x larger than 1. Corresponding expression means sin x. So write it, sin x. X tends to 1, sin x. Corresponding limit equals sin 1. Left-hand limit exists equals 1. Right-hand limit exists equals sin 1, but they are not equal. They are not equal means corresponding fx has no limit if x tends to 1. Now look at example 4. Determine the limit absolute value of x over x if x tends to 0 exists or not. The result doesn't given. This means please determine exists why. If it doesn't exist, give us the reason. So now look at this. The left hand limit x tends to 0 from the left side. X absolute value over x. X tends to 0 from left side. This means x is less than 0. Less than 0 means it's a negative number. So the absolute value equals minus x. Minus x over x together equals minus 1. Limit any real number equals itself. So equals minus 1. It is our left hand limit. How about right hand? Now look at the figure. At this time, the limit is minus 1. Corresponding the right hand limit, x tends to 0 from the right side, equals what? The absolute value of x. At this time, x is a positive number. Positive number means the absolute value equals itself. So equals limit x over x, I tend to 0 plus, equals limit 1. Limit 1 equals number 1. From the right side, at this time the limit equals 1. So the limit does not exist. We have the following summary, the precise meaning of the limit eventual delta. Try to understand, okay? For every eventual less than 0, there is just corresponding delta less than 0. Eventual is given, try to find the delta. Such that if x minus x0 absolute value less than 0, less than eventual. How to understand? This means less than 0 doesn't include the point x0. We always have f minus l absolute value less than eventual. So now look at the following questions. Question 1. Prove the limit x tends to x0 equals x0. How to prove? According to the definition of limit, for every eventual, try to find the delta. So now look at this. F minus L. In this question, the function means x. So copy x. How about the limit? limit means capital L equals x0. So f minus L equals x minus x0, corresponding to absolute value. For any epsilon less than 0, take delta equals epsilon. That means epsilon is given, delta will be given. At this time, for any x, means if x is changeable in this interval, x minus x0 less than 0 less than delta means delta equals epsilon. We always have f minus L absolute value, because the absolute value equals x minus x0. X minus x0 less than delta. In this question, delta equals epsilon, so less than epsilon. According to the definition of limit, we will have the limit x tends to some fixed point equals the fixed point x0. Now look at question 2. Prove if x0 less than 0, the limit x tends to x0 square root x equals the square root x0. Look at the given condition. Why x0 is a positive number? Because square root x. Okay, so x to the non-negative number. So the first, the absolute value x minus x0 less than or equal x0. This expression makes that x non-negative. Non-negative means our function expression square root x has a mathematical meaning. Non-negative for x. Why? X is a negative number. For example, minus 5. No mathematical meaning. Because f minus L equals, how about fx? In our question, f is square root x, so copy square root x. How about L? Yes, this fixed number. Square root x0. How to write it? Try to write x minus x0. How to change times something over something? We can write it this form. X minus x0 over square root x plus square root x0, and then because x is a non-negative number, we always have this expression. X minus x0 absolute value over square root x0. This for any epsilon less than 0 in order to f minus L less than epsilon. Less than epsilon, this means only need to x minus x0 corresponding absolute value less than epsilon times square root x0, and x non-negative for the mathematical meaning. So take delta equals non-negative x0. Satisfying some expression means this expression. How about minimum? Take the two values minimum. At this time, take delta equals minimum the two numbers. If x minus x0 less than 0 less than delta, we will have the square root x minus square root x0 absolute value less than epsilon. Always have this expression according to our definition. We will have the limit square root x equals square root x0. Now look at the last question. Question 3. Prove the limit bracket 3x minus 7 if x changes to 4 equals 5. How to prove? In this question, we will give you the analysis process. Look at this analysis process. If you want to prove that limit 3x minus 7 equals 5, in order to find x minus x0, in this question, x0 equals 4. This means x minus 4 absolute value less than 0, less than epsilon. We can get 3x minus 7. It is our fx minus 5. absolute value less than if true. This means 3x minus 12 absolute value less than if true. Try to get what? X minus 4. This means x minus 4 times 3 less than if true. So we can get x minus 4 corresponding absolute value less than if true over 3. We have built up the relationship between if true and delta and if true. So, how to choose delta? We have the idea. Taking delta equals if true over 3. According to the analysis process, we have the correct proof. For if true less than 0, we can choose delta equals if true over 3. At this time, x minus x0, this means x minus 4, absolute value, less than 0, less than delta, implies that corresponding fx minus L, absolute value, equals 3 times absolute value, x minus 4, less than copy 3, delta. Delta means if true over 3, 3 together equals if true, according to our definition of limit. So we have this expression always less than if true. So now class is over. See you next time.